This is 3.2 Polynomial Functions Part 2. So we left off talking about multiplicity and x-intercepts. This is sort of like the book definition of it. It lets us know that if a zero, so remember we have a couple of names for solutions. We can call them a solution. I'm actually going to write this. Solution. We might refer to them as zeros, which can sometimes be confusing because people are like, but how is 5 a 0, right? When we're saying zeros, we're saying, okay, when y equals 0, what is x? So we'll look at that. We call them roots or x-intercepts. So anytime we're talking about those, we're talking about the same thing. We're talking about solutions. So if a zero is of even multiplicity, so remember we said that multiplicity is basically how many times did we get that answer. Then the graph touches the x-axis and turns around. And then if the zero has odd multiplicity, then the graph crosses the x-axis. Something corny that we sort of made up in class together, I think I started it and then students sort of filled it in, is odd Todd couldn't make 2, so he just kept going on through. And so we're saying, look, if the number is odd, then it's going to keep passing on through. Well, I said the number, the multiplicity. Let me correct that. So real quick, let's look at this polynomial function. So here is factored. When I set each of those equal to 0, this will come out with x equals -1. And this is going to give me 2 answers of x equals 3/2. Well, because x equals -1, we got that answer once. That's an odd multiplicity. Multiplicity is just how many times it happened. So odd Todd couldn't reach 2, so he just kept going right on through. So we know that part of the graph is going to pass on right on through at -1. And then we say, even Stephen came to town, but then he decided to turn around. So 3/2 has a multiplicity of 2, which is even. So we know on the x-axis at 3/2, the graph is going to touch and turn around. Now, this polynomial function has 3 solutions, and sometimes that could be confusing if people just say, wait, hold on, I only see it touch the graph at -1 and 3/2, but because it touches and turns around at 3/2, then we're like, oh yeah, that has a multiplicity of more than just 1. In this case, it has a multiplicity of 2. So let's go ahead and try to apply this. Getting your hands dirty is the best way to actually learn it. We can lecture to you all day long, but actually going through the work and doing it really allows you to have those light bulb moments, and then also even know, what question do I even ask? Because a lot of students in class would just be like, I don't even know what to ask. And once they get into the homework, then they're like, oh, okay, these are the areas that I need a little bit of help with. Okay, so here they ask us to find the zeros for the polynomial function and give the multiplicity for each x-axis. As part of the questions covered. I was like, that doesn't make sense. The multiplicity, it probably says for each solution on the x-axis. For each solution, and then tell whether it passes through the x-axis or touches the x-axis and turns around at each 0. Okay. So that's the graph. Let's go ahead and graph it anyway so we could just get that practice. Excuse my little calculator. I do not know how to get it back big, and so I was messing with it, and finally I just gave up. Okay. Let's delete that out. So we have -3, x minus 2, and x plus 7 squared. X plus 7 squared. So I immediately know that that x plus 7 written out, let me just write over here real quick, looks like this. x plus 7 times x plus 7. So the solution that would come from that by me setting it equal to 0 is already going to have a multiplicity of 2. Okay, so execute, draw it out. Okay, so my graph is only showing one line, right? This can sometimes be confusing, and this is why it's important to know more than just what your calculator is going to kick back at you. Looking up here, I know if I set each of these factored portions equal to 0, I would get positive 2 here. Actually, let me write above it because we're going to do some writing below it. I'll get x equals positive 2 here, and x equals negative 7. Sorry, it's coming out not so clear. The screen keeps moving. Okay, there we go. So when I look at my calculator, if I don't know any better, I would just say, oh, x equals positive 2, right? But because I know better, then I can scroll over to the left until I see negative 7. Now remember, I don't want to just trust my eyes, so it's good that we have tools on the calculator, such as GSolve, F5, and then I'm going to press F1 for root, and boom, it identifies the furthest, the leftmost root at negative 7. And sure enough, I see there that it touches and turns around. And then I can arrow to the right, and boom, it identifies x equals 2. So it's always good to confirm it with your tools in the calculator because like I said, there are some instances where it looks like it's 3, but it's really a 2.95 or something, and you don't want to mess that up when you have that tool available. So it says the multiplicity of 2, so it actually doesn't ask you the leftmost 0 here. It tells you, okay, the multiplicity of the solution of 2 is what? Well, it occurred one time. And then the multiplicity of negative 7 is what? So remember, they're just asking you how many times did we get that answer? Well, the multiplicity is 2 because we got the answer 2 times. Does the graph of f of x cross or touch the x-axis and turn around at the x-intercept 2? Well, because the multiplicity of 2 is 1, which is an odd number, remember odd Todd couldn't make 2, so he just went on through, so he crosses. And then does the graph of f of x cross or touch the x-axis and turn around at the x-intercept negative 7? Okay, so negative 7 had a multiplicity of 2, which is even. So even Steven came to town, but then he decided to turn around, so we know that it's going to touch and turn. If I'm like making you want to pull out your hair with my corny rhymes, I'm sorry. That's just the way that I learn, and that's the way that I'm able to help some people. If you're like, I don't need all of that, I can just remember the rules, then go on with your bad self, because that's awesome, because I struggle with that. But for those of you who might be like, it's just going to be rules unless I, find a way to memorize it. And if what I'm saying, you're like, yeah, that doesn't make sense, make up your own then. I highly encourage you to find the way that you're going to get it. It's not a matter of if you can get it, it's just a matter of how. Okay, here we go. For the polynomial function f of x equals x to the 4th minus 6x cubed plus 9x squared. They want to know the end behavior. So this is sort of kind of recapping everything we covered in 3.2. Remember, for end behavior, we're going to look at the degree of the polynomial. The degree of the polynomial will be the largest exponent. So 4, okay? Because 4 is even, then I know both ends will go in the same direction. Both ends are the same. Then I would look over to the coefficient of this leading term and see if it's positive or negative. It's positive, so both of them will be going upward. Remember the coefficient, the positive or negative of the coefficient tells us how the graph ends, what the last tail is doing. And since it's going up and they're both the same, then both of them are going up. Now, of course, we can graph this, right? And I actually would recommend doing that first. We see the graph here, but absolutely do that first, but still confirm that with your knowledge. So if you see the graph and you're like, oh yeah, never mind, it is supposed to be this way, that's okay. But if you're just completely lost and like, I guess I'll graph it and just say, you know, that can be a bit misleading because sometimes our calculator doesn't show the entire graph. And so you'll have to know to scroll solely based off of what you're expecting to see. So end behavior, we say rises left, rises right. Okay. Let's put that in there. X to the fourth minus 6x cubed plus 9x squared. Draw it out. Okay, so we see two spots where it looks like it touches and turn. I know that I'm looking for 4 solutions. If it touches and turn, that can count as 2. If it touches and turns, then it can count as 2. So this works out, but I'm gonna go ahead and do gsolve root. It gives me in the bottom left corner x equals 0 and x equals 3. So my zeros are 0 and 3, which I can totally see how that's confusing because it's like, wait, my 0 is 0 and 3. But remember, it's just, that's another word for solutions, x-intercepts, roots. And then the multiplicity is 2 and 2. Okay? Y-intercept. Go back to the calculator. We're going to press gsolve F5 again. And if you go under F4 or above F4, you'll see y-intercept. Okay? And it tells me it's 0. Is there symmetry? This is a tricky question because you're going to say, absolutely, I can fold that W in half, right? But remember, there's specific symmetry that we look for. Because it is not symmetric upon the y-axis or the origin, right? I could not, if I had this graph on a sheet of paper, I could not fold it along the y-axis. I could not, so that knocks out symmetric upon the y-axis. Or yes, and then I couldn't fold it on the y-axis and then fold it again on the x-axis and have perfect symmetry. So that knocks out symmetry on the origin. So the answer is none, which again, I can see how that could be confusing because you might say, yeah, but I could fold it here. You could, but that is not a symmetry that we consider in this case. Okay, and then graph, we could identify the graph because we just would match it with whichever graph looks like that. Okay, let's do it one last time. It says use the following steps to graph the polynomial function. F of x equals x cubed times x minus 3 squared times x plus 4. All right, end behavior. This can be a little bit misleading because you might look at this and say, okay, I remember you said to look for the degree of the polynomial, and the degree is the largest exponent, which is 3. If it was not factored out, that would be true. But because this is factored out, we have to take into account what this would look like if it was not factored out. So once I would multiply, as I'm multiplying these variables, I would add my exponents, right? If I have, this would end up giving me an x cubed. This ends up giving me an x. So if I FOIL this x minus 3, and then this one's x cubed. If I was just to multiply those, I'm going to get x to the 6. Now, I didn't take into consideration anything else besides my variables because remember, I'm only worried about the power of my leading coefficient. Oops. I meant to erase that. So it actually has a power of 6. A degree of 6, excuse me. That is an even number. So that means that I'm going to have the same ends. Both my ends will be doing the same thing. And then the coefficient on there would be a 1, right? Because there's nothing in front of these x's. Nothing here. That's just a 1. I say nothing, but there's a 1, 1, 1. So what I mean is nothing besides a 1. And so that would give me a positive 1x raised to the 6th power. That would be my leading coefficient. And because it's a positive 1, it means that they're both rising. Now, even if you aren't completely lost, right? Let's graph it. Let's confirm that. Or you might say, yeah, I have no idea how I would have been able to make that determination. So that's okay. Let's graph it. Okay, so x cubed x minus 3 squared, and then x plus 4. Now this is important, especially look at this one. This is important that we know about end behavior because look, it looks like it could be, if I was a little bit scooted off the screen to the right or to the left, or if my screen was smaller, I might think, let me scoot a little bit over to show you. So if I only saw that, I'd be like, oh, my left tail is falling and my right tail is rising, right? Well, that's not accurate because we have a portion over there, right? So end behavior rises left, rises right. Okay, zeros, remember we'll do G-solve root. It gives us that first one at -4. Then I'm going to arrow over to the right. 0 and 3. So -4, 0, and 3. I actually think I'm missing something. Oh, no, that's all of them. Okay. So, how many times does -4 happen? One time, right? It actually came from that one. So if we would have set that equal to 0, that's where I got my -4. The multiplicity is 1. Okay? The multiplicity of 0 is 3. How do I know that? Because that 0 came from setting x cubed equal to 0. And the 3 came from setting x minus 3 equal to 0. And so that has a multiplicity of 2. So because the multiplicity for -4 and 0 are odd numbers, they should pass through the graph. And sure enough, at -4 and at 0, it passes the graph passes through the x-intercept, or the x-axis, excuse me. And then at 3, it has an even multiplicity, so it should touch and turn. And sure enough, we see that. Let me go down a little bit lower. There we go. So you can see it a little bit better that it touches and turns there. Okay, y-intercept, G-solve F4 for y-intercept, 0. Is there symmetry? This is pretty clear that there's no symmetry. None. And then the graph that I'm looking for would be the graph that looks like this. Okay, remember to practice.